Yeah, good morning. So it's very, very hard recording a video in the morning, right? And the reason for that is because it's very, very easy for me to get work engagement and work messages. So I initially started the video, and for some reasons I got like a message at work to fix an issue. So I had to stop the video, but next time I'll try to pause. But the problem with that is this video is not scripted. So I might not remember where I stopped, right? But anyways, I will try. I will post the next time I get a Slack message so that I can, attend to work and then come back. Hopefully I remember. But this time I did not pause, so I have to start all over. This is the very first time I'll be recording a video without without the audience, right? And that's because we've been missing our times lately. And whenever I'm free, they are not. Whenever they are free, I am not, right? So there's been that kind of like time clash and the like. So I would just have to record this video and share so that you guys can so that at least you guys can continue from where we stopped. I know we're talking about creational patterns, right? And if I can remember, we talked about singleton and factory. So there are three creational patterns I was going to talk about, right? Factory, singleton, and then there is the third one, abstract factory. So I'll try as much as possible to keep this class or this talk. I don't know what it is at the moment, but yeah, I'll try as much as possible to keep this talk within a certain time frame. And then maybe if I want to cut, I can. Okay, this is 10:50. So I'll try to make sure it doesn't like exceed like 11:10, 11:20. But I don't think we should. I'll just talk about creational, structural, and behavioral, right? Well, I already talked about creational, so I'll just talk about the next creational pattern on our list, which is abstract factory, right? So what's abstract factory? Abstract factory is the common use of abstraction, right? So this is something that you've seen, whether you like it or not, as a Flutter or that developer, right? You've seen these abstractions in open source softwares and the likes like that, but it's a creational pattern. Same with factory, right? Same with singleton. Right. So everything we've been talking about is something that you most likely would have used, but maybe you don't know where to categorize them in, and this is just me trying to highlight them for you. Right. So the abstract factory pattern is it kind of like provides an interface for creating families. So families of like related or dependent objects. So without having to specify their concrete classes, right? Something around that. So in the sense that say we can use team or team. I don't know. Someone told me it was team, but I pronounce it as team. Right. We can use team for example. Uh, So should I use Steam or Material and Cupertino have? Let's use Steam for example. So we have team, right? So let's say we have material team, material team. Second, let me get bottled water so that I don't die of thirst, right? Wow. So I'll pause this and resume once I get to the water. Yeah, so I'm back, right? So let's say you have material team. Right. I'm using a common example for Flutter developers, so you have an understanding of what I'm talking about. Let's zoom in a bit. So we have material team, and then we have corporate team or term, right? These are teams, whether you like it or not, right? These are teams, and for teams, they definitely will have same properties, same functions, same methods, right? So let's say you have primary color, uh, color primary color, right? And then so let's say we do this color color. Yeah, so we have white, black, uh, blue, red. Uh, yeah. So let's say we have this, right? White, black, blue, red, and so we have color. Primarily color. We want this to be red, so color dot red. So we have this, and we want the primary color of our material theme to be blue. We have this, right? So this is very, very interesting. But what you realize, okay, that's a call. But yeah, what you realize is whenever I want to update something, whenever I want to update something, hmm, okay, so whenever you want to update something, say you want to add a secondary color, say you want to add a secondary color, right? So red, um, secondary color, blue. We have to always duplicate this, right? So these are families, but and they have related and dependent objects, but yeah, the way we can actually make this work using the abstract factory pattern is, we create a class that that contains the common or related objects they share, right? So abstract class, which is definitely team. Just wait, what's going on? Which is team, right? So we create an abstract class called team, and what we can do is primary color, and then what other things? Okay, color gets secondary color. So by default, right, when you implement this thing, you don't have to go through the stress of having to specify which is which, right? The family, because material team is a family of team, right? Same as Cupertino, already knows, what to implement and what to override. So once we implement team, all we just have to do is override, override, right? Same applies to this, right? And let me show you how easy it can be. Your IntelliSense will just suggest implementing to you. Class material team implements team, right? So already you get an error saying missing concrete implementation of team primary color, right? Because as a team, you have to have the primary color, you have to have the secondary color. So it's just very easy. Create two missing override, and then if you want to throw an implemented, fine. But yeah, color the red. I hope not color the red, and then color dot black. Yeah, so you understand what factory pattern means. So it's just more or less like, creating families of related or dependent objects, right? So, and that is without having to specify their concrete class. So we already know that any family of team would have a primary color, will have a secondary color, would have an accent. We can list everything here, right? And then if you want to use, say you want to use material team in another class, right? Say you have a class, or you want to just use team, let's say material hub, right? Material hub, right? Say you want to use this thing. You don't have to specify if it's Cupertino or it's material. So implement. So what you can just do is final. Okay, so Yeah, that's right. What you can do is final thing, right? Create constructor. Yes, create constructor for final fields. We can allow moving it up. I think is a rule of thumb for Flutter developers to move the constructor above the Flutter and their developers, by the way, to move the constructors above the fields. Anyways, when you're using this in like your void main, run app, so to ask me for a run app function that takes okay. So this is we just reinventing the wheel for Flutter here. So we have material app, run app. So what we can do is abstract class app, abstract class app. So yeah, so this takes in an app, yeah, something like that. It takes in an app and perform whatever operation needs to be performed. I Yeah, it performs whatever operation needs to be performed. Abstract class app. So material app would implement app, right? Because it's an app, we can decide to have a Cupertino app. Tino app implements app, right? And then yeah, whatever happens here, running app. So what we would have in our void, for those that are familiar with Flutter, right, is run app, and then we can pass in material app. So app should take in themes by default. So final or theme, yeah, yeah, final theme, and create constructor for final fields. As usual, move it up, and then so final theme. We might not want to do this super dot theme. Oh, sorry. Yeah. So we have to implement because it is not implemented here, right? So we have to implement theme. So for material app, we might want to go to with material theme. Yeah, might want to go with material theme. And so material app implements blah blah blah. So for Cupertino to same thing, Cupertino team, and then run app. Let's say you want to run material app, you can run material app. Let's say you want to run Cupertino app, you can run Cupertino app. So you see how we don't have to use the concrete implementation. We don't have to specify that run app takes Cupertino or material app. As far as it's a family, it will always take it, right? So you understand what abstract factory does. So majorly this is what abstract factory does. This is 1102. So yeah, the next thing we want to talk about is structural patterns. So talked about our creational patterns, right? Um we we have some other patterns. We have structural and then we have behavioral patterns, right? So what I'll do is I'll create another folder here called structural patterns. Structural patterns. So let me attend to the call I had and come back. So I'll pause and then resume. Yeah, so I stepped for a call and yeah, this is 1:39, but I'm back. I think I can pause this for as long as I can. So I'll just pause, resume, pause, resume, pause, resume, pause, resume I till I'm done. Right. Well, yes, I'm glad this functionality is there. Anyways, let's see how long I can before I get another message. This is why recording video during work hours is kind of like a bad idea. But anyways, back to my talk. So we've talked about creational pattern, and I know I created a new folder called structural pattern. right? So what are structural patterns? So structural patterns are patterns you will see a lot in Flutter because I assume a lot of developers here. Though I know that definitely Flutter is not the only framework on that, but at least 80% of that developers, at least, right, would be able to write Flutter to an extent, right? So yes, these are patterns you're going to see in that a lot of the time, right? So structural patterns kind of like deal with, the composition of objects, right? In the sense that, creating relationship between objects to form like a larger structure. So the examples would allow us to like, look into this, right? Um, so for instance, now there is the adapter pattern, right? In the structural patterns, there's the adapter. Um, there's also the decorator pattern, and then there's the composite pattern, right? So I would start with like, the adapter pattern. The adapter pattern kind of allows, incompatible interface, right, to work together. So it kind of like, acts as a wrapper for an existing class with, a new interface. So a very, very good example for that should be uh let me just create a new file called adapter pattern, right, with that. So like I said again, some of those things if you're writing like that code, Flutter code for like a year, 2 years, you should see this, right? Because I knew that I was already using this, right? When I started writing that for like 1 year. But anyways, this is just like the implementations in that, and it's not specific to that, by the way. These are common patterns like we discussed in the first class, right? Where I talked about the fact that this is kind of like, the idea of like for for guys, right? It's called like gang of four or patterns. But anyways, let's enough of that. Like let's just talk about the adapter pattern. So yeah, let's create an abstract class for a data source. Abstract class data source. Abstract class data source, and let's say we have a list. I don't want to create too many classes like I've been doing earlier. Let's say we have a list of type string. Jeez, I can't believe I still make mistakes while typing. But anyways, get data. Yeah, so we have an abstract class with a get data function, right? So let's say we have an API data source. So we have an API data source, right? Uh yeah, class API data source. So I am not seated on my seat, so typing might be a bit inconvenient for me, but anyways, so we have API data source. We have like a function called fetch data. So future most likely I don't want to create a new object, so I'll just use map string dynamic, right? Because we're just imitating what like an API call would be dynamic and fetch data. Fetch data can make it asynchronous, because why not? Right. There's something wrong. One what to? Oh, okay. So because there's no return. Yeah. Sorry, I was assuming this was void. So if it was void, we shouldn't get any error, I believe, because it's not expecting any return value. Okay, so back to this. So we have to return at least the map. So let's say we have a data. This is me just imitating um item one, item two, item two, like item three. I think this is good. Item three, right? So yeah, we have this API data source that has a function that says fetch data, right? And then we have yeah, majorly that is it. So this is we just simulating API call. So simulating API call. So let's create an adapter that implements, data source. So yeah, class API data source adapter, and it implements data source. And for this, we can pass in the API data source final API data source API data source, right? And create a constructor for these. And as usual, we move our constructor up above our fields, and yeah. So we can override this and final response equals to, let's make this asynchronous, await API data source dot fetch data, right? And then we can return list dot from, so it has to be a list of type string, right? From response and data. So if you see what is happening here, abstract class data source returns a list of string, right? API return a map string dynamic, right? So you can see these are different. These are different. These are different incompatible interfaces, right? They are different. They are not compatible at all because the function here returns a map. So we need a way to, adapt the different data sources, right, to like a common interface. And that is where an adapter comes in. So this is what the adapter pattern looks like. You would see that a lot when you're working with Flutter and you're doing like baseline API calls, right? But yeah, most likely you've used it before. I might not know it is called an adapter pattern, but this is an adapter pattern. This is like a real world example of what an adapter pattern is. Right. So I believe that is it. The next item on my list is structural pattern. So this oh shit, did I say structural pattern? Sorry, not structural pattern per se, right? Structural pattern is the group. Adapter pattern is a type of structural pattern. The next one is decorator pattern, right? Decorator pattern. So this one you would see a lot in Flutter. So this is something you would see a lot in Flutter, and I would give you context. You know what? Let's just create this. So decorator. So a lot of you might have used this. A lot of you might have used this in Flutter a lot of the times, right? But I would just like, put it into writing for you what you've been doing. So decorator pattern. So we have say we have a stateless widget. Okay, so this is not a Flutter project. Creating a stateless widget is going to be tricky, but I think I can still try something. Okay, abstract class stateless widget. Um, it doesn't even bring out the suggestion. Interesting. So, anyways, we can have like a class login button decorator. Extends stateless widget. extend stateless widgets. So we have a widget for stateless widgets. We have a widget build. This is we simulating, by the way. So we need a widget. Uh, shit. Shall I make it an abstract class or a full widget? We'll find out if I need to make it an abstract class or a full widget. So we have widget build, create one missing override. So we have our guy here. So we have widget that needs to just return a widget class, a widget class. So no, let's make this abstract. So the abstract class widget. So we have the fact that we have to simulate all these things from scratch. But anyways, I think it's going to give you like a fundamental understanding of what how all these things works in the background, right? So you know that okay, fine. Now widget is an abstraction of is an abstracted class. You can I don't know, you can check what it is made up of, but yeah, it's an abstracted class and it just contains like some functionality, some things, right? Like a widget can have a child and the likes. Anyways, this might not be the exact way it has been replicated, but this is we just like simulating what widgets would look like an I2 work. So you can look at it from this perspective also. But anyways, we have a widget. So one of the widgets we need is a gesture detector. Let's just say so for a widget should have a child. A widget can have a child. It's way more complicated than that, but yeah, widgets get child. A widget should have a child. You're supposed to be final, create constructor, generate constructor. Let's remove this stupid. Yeah, so generate constructor widget, return widget for now. Oh, so we can return widget. So we need a gesture detector. So uh gesture detection, gesture gesture detector extends a widget, right? So we just know it takes in a child. That's what we know. And then here in the login button decorator, you can have a gesture detector that takes in a child. Yeah, so final widgets, final widgets, child. I just hope I'm not complicating everything for myself and for you guys. But yeah, this is I should have just created like a Flutter project. But yeah, this makes it much more fun, right? Than me just explaining and not really like, doing anything to like, represent my explanation. Anyways, I could have just represented the suite. Well, this is we building it from scratch, so you understand. So, yeah, so we have login button decorator, which is a stateless widget, which is a stateless widget. Yeah, this is the tricky part. So the thing with decorator is, say, how best can I put this, right? So the decorator pattern kind of like, it attaches additional responsibilities to like an object dynamically. So the idea here is, say you have a button, right? Uh, Writing all these things from scratch, I don't think it's going to be a very great idea for me. So what I'll just do is I'll like build a comment or a void mean a code that doesn't run anyways, and use it to explain what decorator pattern is. And I know you guys will remember this from Flutter, right? So decorator pattern kind of like attach additional responsibility to an object dynamically. So for instance, now this login button decorator, let's say I have an elevated button. Let's say I have an elevated button. No, let's try this. Reject, return. Let's say I have an elevated button that is also a widget. Elevated button that is also a widget, extends widget. Let's say I have an elevated button that is also a widget. Um, I can decide to return elevated button here, right? Which takes in a child, and the tree continues. So what we can do is we shouldn't require child, right? We should make it nullable because sometimes we don't need a child. For instance, this case, we don't need a child, so it shouldn't be required. It shouldn't be required. Elevated button shouldn't be required to. So yeah, so what we can do is we can wrap. We want an added functionality of the gesture detector, which is that thing that allows us to click on button, but we want to override whatever is here and wrap it. So what we can just do is instead of returning elevated button, we can just return gesture or gesture detector, right? And return elevated button. So this is we overriding. So this is, oh sorry, we return login button decorator, right? Which at this point would not take our yeah, would not take our widget into consideration, but I will change the return type. So this login decorator allows us to attach an extra functionality of gesture detection. I don't know if you understand. The decorator pattern can be used, can be seen in containers, right? Like container is the easiest example. So when you want to design containers in Flutter, you attach a an object to it, right? You attach an object to it, which is called, it could be box decoration, right? Where it contains some functionality that can be attached. That box decoration can also be taken and used somewhere else. So that's what the decorator pattern is all about. So I believe now you can understand that, oh yes, these things I've actually been using it. I just, kind of just put a name to it, right? And anyways, I'm happy I'm able to like share my view on my understanding on this topic itself. So we this is 32 minutes already on the video. I don't know if I want to go very, very long, but I'll talk about the last structural pattern, and then I know the next video I'll be making would be as regards behavioral pattern. Yeah. So when we talk about behavioral pattern, we can talk about architecture. Architecture is right. Yeah. Anyways, the next pattern is composite pattern. So this is something that this is something Flutter is being built on itself, like for your Flutter code, right? It uses something called a composite pattern, right? So kind of like composing objects into trees and structures to represent like a part to represent hierarchies majorly, right? So it allows I don't know, clients, right, to treat like all these objects and composition like uniformly. But anyways, I'll just give an example of composite pattern, and we can call it like a wrap, right, for the day. We can call it a wrap for the day. Or okay, there's one more pattern I might be missing. Okay, so okay, I already said I was not going to talk. I was going to look at behavioral pattern. I can remember I said I was not going to talk about behavioral pattern. All right, I'll talk about behavioral pattern in the next video because I can see this is already getting long. So what I'll do is I can choose to record anytime later. And yeah, anyways, back to our composite pattern under structural patterns. Composite patterns or pattern. So, like I mentioned, it composes object into like three structures. And yeah, abstract class, firstly, abstract class components. So this would help you understand. Then we have a widget build. Um, abstract class widget. Yeah, we have abstract class widgets. We have abstract class components. Um, say okay, okay. So this, I am trying to think of a name to use for this. Uh, leaf. Is that a great idea? Is that a great idea? I'm trying to think of a name for this. Uh, so random components. So random components. I we can figure out the name, right? But I needed something that will be explanatory. On the example that I am thinking about, the example as like it might make it much more confusing, right? So I'll just use random component for now. Random components, and then implement components, which definitely. So so it's almost the same thing like we did earlier, but anyways, now we're talking specifically, then we're talking about decorator, now we're talking about you know composite. So yeah, the next thing is component. Let's pass in a final widgets, and then we can create constructor create constructor for final fields, move this up, and yeah. So we have widget build, blah blah blah. Um, so instead of this, we can just return widget. Instead of this, we can just return widget. So for composite, this is where the composite person is being implemented, and you see the relationship with what you're already doing in Flutter in a bit. Implements components. So we have composite implement components. Um, yeah. So what we can do is let's create a column widget. Having to create this thing from scratch might be a bad idea. It's class column. I'm not sure I have too many choices here um aside having to create a new project that will be Flutter focused so I can use all these already created classes. So we have column. What does column require? We require children, which is a list of widgets. Children, create constructor, create constructor for final fields. That's and column is a type of widget too, so we have to implement widgets. Now this gets confusing. I want to experiment something. So implement widget. Yeah, meaning we don't really have to do anything. I will, yeah, yeah. It doesn't implement a component, so it's still a widget, meaning we don't have to do anything, do we? Yeah. Let's hope this works, right? This is an idea I'm manufacturing in my head. So if you are not calling any function here, then yeah, this is fine. We are just trying to represent a column. So yeah, so the column widget, right, takes in a list of children. So what we can do is this composite takes in a list of components, a list of components. a list of components, and then we call this children too. And we can create a constructor for this also. Move this up as usual. And yeah, so in the build, we're returning a column in which the column should be a type of widget. I hope so. Yeah, it is a type of widget. So what we can do is just to make it feel more Flutter-like, we can make you nullable children, children. And then what we can do is children dot map. So this is a child, right? Singular, plural, children. Okay, this is a child. So child dot build, which returns a widget, right, to list. Yeah. So I think I'll just need to add comma here. Okay. So I'm just trying to keep it in screen. So this is what the composite looks like, right? So in order to use this, right? So we can do final UI. So this is we reinventing Flutter, but our own version of Flutter. So there's no really deep thought process into it, but we are following like a true structure. You know the way your material app starts, and then it has a home value, then the home leads to widgets, then the widget leads to deeper widget, and it goes deeper. So that's what composition is, right? So final UI is equals to our composite widget, right? So this composite, we can call this uh can we call it our material app? To be fair, but I feel like you guys get the picture though. So composite, and then it takes in a list of children, and list of children, a list of components, right? So what kind of component do we have? We have random components. Thought I copied random. Random components that can take in a widget. A widget can be class, container, container, container implements widget. A widget can be a text widget. So we just have this random representation of widgets. And then we can come back here and say, oh yes, composite, random component, we pass in the text widget, the text widget. We pass in a text widget, right? Yeah, what other second implement component. So another thing, another interesting thing, right, is you can you can actually in this pass in another composite. So that's what makes it like that's what makes it cool, right? You can pass in another composite, pass in another child, right? And pass it in again like that. You can just take it. So you can see what the tree looks like. There's a composite, then it has children, random components, um, text, blah blah blah. So yes, this is what the composite pattern looks like. It uses this kind of like hierarchy structure, right? And yeah, majorly that's what your composite pattern is. And I believe this should be like the end of like my structural pattern stock. Yeah, so as you can see, it kind of like composes objects into tree and structures. So kind of like an hierarchy that can go as deep as you want. The same way your Flutter app can go as deep as you want, right? It spreads. So that this is what composition is. I hope you guys understand. I don't have any audience to ask at the moment, but if you do have questions, please do well to drop in the comment section. I would maybe pick it up and answer in like my next video or something. and then or in the next class, depending on what happens next. But yes, do well to subscribe and like and drop comments, opinions on topics you want to have. Hopefully, I am very consistent with this, but I think I have been trying, right? I think this is like the third or fourth video already. I don't think I've done 4 videos in a year, so I think I should give myself that credit for that. But yeah, thank you very much for like, joining the or watching this video. It's not a meeting. See you another time.